you dengar pakai ni jangan, you tengok dah ada start. Dah start Huh? Okay. 1 more minute, I think we start.
Sritar, you should start now, Sritar. It's already started.
Sorry. Oh, okay, I thought it was wait until 4 o'clock. Okay, good day to everyone who's joining this distinguished lecture series. My name is Sridhar Raju, Associate Professor at UTM. So we are from a research center called LOCATIC, UTM Center for Low Carbon Transport, in cooperation with Imperial College London. So today we have a lecture from a professor who made all this thing happen, Ricardo Martinez-Botas. So before we hand over to him, allow me to give a bit of brief about our center. So LOCATIC UTM is a center looking into research and activities encompassing what we call this research that involve in reducing carbon emission from transport and a bit on the energy. We established in 2014, so it's been about 6 years, and in these 6 years we have worked very closely with Professor Ricardo Martinez-Botas in making what we call collaboration with industry partners, in making publication happen, in making all our activities to be visible to the outside world. And so in all these years, we have published more than, I think, 200 index papers. We have attracted millions ringgit in funding from external parties, and we work very closely with key industry players in transport industry, also a bit on the energy industry, looking into contributing our fair bit share on reducing carbon emission. Okay, so that's a bit about UTM LOCATIC. So for now, I think I'll pass to the Dean of Faculty of Engineering, University of Technology Malaysia. So he will tell you about Professor Ricardo Martinez-Botas before we move on to listening from him. So, Dr. Rafiq, it's your sound.
Thank you, Sritar. Thank you so much. Assalamualaikum, hello, welcome everybody. Welcome to our 19th UTM Engineering Distinguished Lecture Series. My name is Muhammad Rafiq and I am the Dean of Engineering, University Technology Malaysia. Today, it is my utmost pleasure to welcome Professor Ricardo Martinez-Botas from Imperial College London. A bit about our presenter today. Ricardo Martinez-Botas is a professor of turbomachinery at the Department of Mechanical Engineering, Imperial College London. Ricardo has an MEng honours degree in Aeronautical Engineering from Imperial College London. He obtained a DPhil in the Rolls-Royce University Technology Centre at the University of Oxford in 1993 with a thesis entitled Annular Cascade Aerodynamics and Heat Transfer. He has developed the area of unsteady flow aerodynamics of small turbines with particular application to the turbocharger industry. The contributions to this area center on the application of unsteady fluid mechanics, instrumentation development, and computational methods. The work has attracted support not only from the government agencies, but also from industries. His group has become a recognized center of turbocharger turbine aerodynamics, and more particularly in the application experimental methods and one-dimensional calculation procedures. In 2010 and 2009, he was awarded the Best Paper Award by the Turbomachinery Committee of ASME and in 2011 has been given the Dougal-Clark Prize by the Institution of Mechanical Engineers UK for contributions to internal combustion engines. He is a visiting professor in the University Technology Malaysia, and he has published extensively in journals and peer-reviewed conferences. He is associate editor of the Journal of Turbomachinery by ASME and the Journal of Mechanical Engineering Sciences, IMechE. And I must add here that he was my lecturer, he was my professor about 20 years ago when I studied mechanical engineering undergraduate at Imperial College London. So that is a biography of our speaker. Here now is Professor Ricardo Martinez-Botas from Imperial College London to talk about the evidence of road vehicles' CO2 and harmful emissions. Professor Ricardo Martinez-Botas, over to you.
Okay, thank you, Rafik. Thank you so much for inviting me. And first of all, welcome to my house. That's where we are now able to meet up. We are able to meet up in our own particular area. So this is my my house, and you are welcome into it. And today I chose a topic which is entitled, as the Dean just told us. And really what I want to emphasize is what is the evidence behind our concerns when it comes to vehicle emissions, and what is the actual evidence that can support the policy of governments. That's really the major topic of today. And the topics I'm going to cover here. I'm going to talk about vehicle emissions as the route to which we got and where we are in regulations. I'm going to talk about the testing done on our roads in the UK. I was the overseer of the biggest emissions testing in the country, and following the Volkswagen aftermath. So I'm going to spend most of my talk about this. I'm going to just show you the evidence. We're all engineers, or most of us are engineers and scientists. Hopefully there'll be some policymakers interested also on what I have to bring up. And so I'm going to spend most of the time looking at the evidence. Towards the end, I'm going to talk about the emissions gap, the gap between, in this case, diesel-based NOx emissions as well as CO2 emissions. And if time allows, I will do some looking at the future. So this is my talk, and I'm now going to concentrate on two elements, mostly two types of emission levels, a lot of it about NOx and some of it about CO2 and contributions to CO2. Much of this translates to gasoline engines as well, and certainly all of it translates to heavy-duty trucks, buses, and other machinery on our roads. So you can see from the UK in national statistics of air pollutants, that is the kind of progression. If you start at 1970, we can see a substantial decrease from all emission levels. They're all centered at 100%, 100 units in 1970, and we can see how they project downwards. This is air quality in the country on average. And we can see all the level emissions going down. We can see NOx dropping 69% in that period, from 1970 to 2014. Particulate matter, sulfur dioxide, non-metallic organic compounds, ammonia staying more or less the same. It was never really that high. And so clearly we've made some effort. We made some substantial progress in emission standards. Our air quality has got better. Our pollutants have gone down. And mostly has been provoked by regulation. This is the place where politicians, where our regulators, where our air quality experts play a role. They play a role in sustaining a decrease that industry resents. Because industry, of course, has a product to sell, has a product to enable, and has a customer to satisfy. So, of course, our regulations enable them to get better products. And that is costly and is time-consuming. And so we see a substantial decrease in all air quality. This is just global air quality in the UK, as published. If we look at emission standards from vehicles, on the top diesels, on the bottom petrol, we can see that the Euro standards have enabled these changes. Just focus on a few of them, particularly on NOx. You could focus on the others. You can see that from Euro 3, the NOx standard in grams per kilometer was about 0.5, and that is been reducing to get it to Euro 6, which is around 0.08 kilograms of NOx, and 80 grams would be the figure per kilometer, and 180 grams would be the figure for Euro 5. Equally, you could see the emission standards being of course much lower when it comes to NOx in a gasoline environment, but higher in other matters. So all in all, of course, the standards have forced a change to the industry. And if we can see ourselves at Euro 5, possibly where Malaysia is sitting, Europe is now Euro 6A, Euro 6B, now RDE, so even more advanced emission standard reduction systems. If we then perhaps look at the improvements, because look at the positive side before I can tell you a lot about the negative side of our air quality provoked by vehicles. The first one is here. The NOx limit is of Euro 6 is 90% lower than 1992. So that's the reduction from 1992, that emission standard, to today is about 90%. If you look at the difference between Euro 6 and Euro 5s, you can see, or rather I can say, that Euro 6 is reducing that emission level by 44% relative to Euro 5. So it is worth going from Euro 5 to Euro 6. It is a very substantial decrease of NOx and other emittents. Meeting the standards in busy roads remains a challenge, remains a huge challenge. In some areas, and if you take big cities, conurbations around the world, whether it's Kuala Lumpur or Johor in a busy day, you would say that, vehicle emissions account I'm not sure. I don't know what happened to the internet. I hope you can still hear me. If so, okay. Can you hear me? Yes? Hello?
Hello, Prof. Can you hear us?
Yeah, can you hear me now? Yes.
Yes.
I don't know what happened. So, unfortunately, I had to go onto my mobile phone. I don't know what happened to the internet. It's rare. So, can I proceed?
Yes, please. Yes, please.
Okay, I'm sorry for the last few minutes.
It's okay.
I'm not sure. The internet has gone down in the area. So I was trying to explain here how our emission standards have improved over the years, and I was focusing on this 90% reduction of CO2 of NOx since 1992 of Euro 6, and then the difference between Euro 5 and Euro 6 is 44% improvement. So it is worth going up to Euro 6 because you can get a substantial benefit on an air quality. Typically, 80% of the roadside emissions come from vehicles, and the remainder comes from all the systems, whether they be tires, whether it be nearby industries, whether it be nearby household emission flues and so on, and local industrial sites. But 80% does account for of our air quality's vehicle emissions. So with that in mind, we did a testing program. We reported to the UK Parliament in some years ago, not long ago. And here's the independent assessment I undertook. This was the biggest program we've undertaken on vehicle emission testing. It's about a substantial investment, and I was the overseer. And I'm going to tell you today about this. So we need urgently evidence on vehicle emissions. We looked at the world, we looked at published data, we looked at what we could ascertain, we looked at companies, industrial partners, and automotive companies, and of course, none of those was sufficiently robust for us to take any policy decisions. And so whether we can, it's a question of trust, whether it's a question of evidence, I don't particularly care. The fact of the matter is there was no evidence and there was no trust, and there still remains a marginal difficulty in trusting our industrial automotive companies, simply because of the aftermath of what happened to the Volkswagen cheating scandal. So with that in mind, we needed to do something, and so it was. And today I'm going to report on this, and I'm going to say how we undertook it. We looked at all the top-selling cars. We tried to capture 75% of the top 70 vehicles, so that we can capture a large proportion of all the vehicles outside. Diesel vehicles, we try to capture all manufacturers that are major sellers in the UK. We, of course, where sharing of a vehicle class or engine class was possible, we wouldn't repeat the testing. We had an even split between Euro 5s and Euro 6s, and we tried to get a snapshot of NOx performance. That is a major endeavor that took the best part of 9 months of many tens of people and lots of investment by the UK government in order to produce a report that confirmed what I'm going to tell you in a few minutes, confirmed the difficulty in vehicle emissions as we see it today. And this is only a few years ago. I wonder if we did the testing today, whether we would see a substantial difference. Well, I was out of the internet. I was commenting on how lockdown has changed this, and lockdown since the 23rd of March or so in the UK, with a relief of lockdown in the last few weeks, has produced several effects. The first one is I can see the skies a lot bluer here in London, and we're not quite in the middle of London, Twickenham. If you're a rugby fan, you can see there's the Twickenham Stadium nearby. Second thing, we can hear the birds a lot more. In fact, the birds are singing louder than ever. And the third thing we see is fewer cars and scents and smell, which is somewhat different. Of course, the UK government is taking care of measuring the standards during those lockdown events, which lasted many weeks. And we will have some information that you could say during lockdown, during this COVID crisis, the level of air standard in our city, in London particularly, in all these big cities in the UK, would be the lowest possible. as there's minimum movement, there was minimum vehicles on the roads, there was an extended period of no significant emission level, one would say that is the minimum standard. So we will see that in the next few weeks, I am sure, as our ministers are looking into it. So this was our methodology. We didn't want to interfere or intervene or communicate in any way, shape or form with the car makers, just in case they provided us a car where we had to ask questions about. So we outsourced them from car hire fleets, many tens of vehicles. We had they had no modifications or defects. They had to be under 30,000 miles, and we used the same grade of fuel for all. We undertook 2 tests with 2 pieces of equipment. The first one is the standard laboratory-based equipment, which is a large equipment, similar, maybe it will occupy the entire size of my lounge here behind me, and it contains a dynamometer with 4-wheel drive and an investment of many millions of pounds. And that's how we would do the testing normally for certification. The second way of doing it is we hired a PEMS, a particle emission measurement system, which you will see a figure in a minute, in which we adapted and joined to the exhaust pipe of the vehicles. And then that was carried with the vehicle through the testing. So 2 sets of equipment, and the first one was on the dyno. So this is a vehicle which was from the Volkswagen group, which we put into the standard vehicle certification procedures, and undertook the vehicle certification procedures as given at that time. And here you see on the right-hand side the speed trace needed. So 0 kilometers per hour, 240 kilometers per hour, and it's the faint gray line, which I'm going to trace with my mouse. So this would be what the dyno, this equipment, will be doing. It will be forcing an acceleration and deceleration following the gray trace at lower speed, and finally mimicking a high-speed drive in a motorway over 1,200 seconds. And that is basically how the test was done up to that point. A car will be taken into the lab, will be undertaking this sort of testing in a certification manner with an independent overseer, and they will say, yeah, it meets the standard. So here is the meeting the standard for NOx, is the red line, or rather orange-looking line, yes, rather low because it's low speed. And when it gets to the spiking, or rather higher speed trace, 100 kilometers an hour to 120 kilometers an hour, motorway mimicking, yes, there will be a bigger NOx impact. What we did is we simply took the vehicle and then slightly modified the testing by putting the high-speed element, the fast element, ahead of the slow element. So we just simply modify our testing procedure and say, right, let me take the lower speed to later, and let me take the high speed to earlier. Now, the consequence of doing that should be nil, should be nothing, because there should be no difference to the standard. It wouldn't matter whether the vehicle is going low speed portion of the testing procedure and high speed, or high speed portion, lower speed. We'll all agree with that. But the fact of the matter is, once you did that, you can see Volkswagen cheating procedures right there in front of you. If you haven't seen it before, this is the real evidence that Volkswagen was cheating in the biggest possible way. Because the moment you switch and slightly modify the testing procedure, and the green appears. Now, green is much higher than orange, and it's much higher because the vehicle emission equipment, the equipment that controls the ability to the vehicle to emit more or less, has been cheated by us. We've simply said, reversing it, modifying it, the software which they coded into the vehicle is now not capable of recognizing the cycle. Now it doesn't know that the engine and the vehicle is undertaking a testing procedure. Now we have cheated the cheat, and therefore you can see what happens. This is how effectively Volkswagen was caught out. And indeed, you can see the substantial evidence. As soon as the vehicle knows that it's been tested, it automatically switches on the emission cleaning procedures. I don't want to go into any more details, through EGR mostly, and then it appears to be clean. The moment that that is not the case, it reverts back to a situation which is harmful and not according to the law, in my view. Okay, one can argue endlessly over this matter. So then we said, right, if we now take a different Volkswagen Group vehicle which does not have the recognition software, well, indeed, it doesn't make a difference whether you go forward or backwards. Green and orange approximately the same, low or rather low. So that, of course, we knew that there were vehicles out there that would be cheating. Now, the question was whether, the number one question irrelevant to our seminar today, was whether there was any other vehicle testing that we tested with a similar software recognition in it. And there weren't any. Of all the plethora of vehicles we tested, there were none. And you can see this by this evidence. This is a summation of all the testing. This is not just one vehicle, it's many tens of vehicles tested on the lab, where the standard would have been 180 or 80 in Euro 6, Euro 5 with 180 milligrams per kilometer. Mara said that incorrectly previously. It was grams per kilometer, 0.18 or milligrams per kilometer, 180. And so, no, indeed, more or less, all the vehicles comply to the standard. They basically, blue is the only thing I want to look at. They do comply. So we actually did not find any vehicle, apart from the Volkswagen Group, that particular engine class, that had cheated the vehicle emission certification procedures. And that was many vehicles. So at least we satisfied one element that said, no, there aren't any other outliers out there that are trying to cheat in this manner. So we leave to one side Volkswagen for now. We did our job. Our job continued because, of course, we wanted to know what is the real level of emissions. What is the public exposed to? Why I say our cities, our environment is not, we'll see in a minute, why it's not a good place, why we are not in a good place yet. Why are we having such an enormous pressure to electrify, to get rid of, to remove, make obsolete our internal combustion engines? And you'll see why in a minute, because the situation is not brilliant. While you would say here in blue, the average of the fleet of vehicles tested that represent 70% of all vehicles in the UK is below the standard. You can see that gap, and equally for Euro 6. When we look at taking those vehicles on the road, a different thing emerges. Before we do that, let's do another experiment. This is a second experiment we undertook. We said, right, let's get our portable emission testing procedure, put this piece of equipment on the vehicle, connect it to the tailpipe, and now we're going to undertake the same cycle that we undertake on the laboratory with the dynamometers and the rollers moving the vehicle, but we're going to do it outdoors. We're going to simply say, go to Mara, beautiful place in the UK, a beautiful track, mostly done for sports as well as certification, and we're going to take the vehicle, I don't remember the order, and go around the track, following precisely this schedule. We're going to say for at 100 seconds, we're going to be at ramping up in acceleration to about 50 kilometers an hour, and so on and so forth. This I witnessed, and there was, of course, a driver highly experienced following a digital meter, and the driver would be accelerating and decelerating, following with some precision, to say bluntly, with total precision almost, this schedule. And we now, you would say, should there be a difference between this on the outdoors and the indoors testing? Well, you might say there is some difference because, of course, there is an environment around you which is different. There's some cornering happening on the track, not a lot because you can see those straights. Could be some additional reasons, but you would say in principle there should be no fundamental difference. And yet when we did the testing, we found this, and we're going to go down and drill down a little bit more. We found that on average, that average emission was by no means anywhere near the emission average here in orange compared to green compared to orange, whether it's Euro 5 or whether it's Euro 6. So the average environment on the lab and the average environment on the track were massively different. Now you've undertaken, remember I said, if we look at it as an automotive engineer, you say I'm undertaking the same trace, I've done the same similar situation. And yet I'm experiencing now something a lot bigger on average. And specifically, if you look at specific vehicle classes, we would say, well, if the standard which they all met on the lab was 180, slightly below, remember, but when it's hot, maybe around 200, when it's a hot environment, the engine was hot and it was properly done with a proper fair-to-fair comparison, or 80. Well, there are no vehicles on Euro 5 that meet that standard. There's some vehicles in Euro 6 that did meet it. They're all well above, and some are, 2,200. So Range Rover Sport, a previous version to the current Range Rover, it's got better, I must say. Look at that level, or the Vauxhall Insignia, and it should be meeting around 180. And the Vauxhall Astra and the Citroën. Well, I don't want to pick any manufacturer, although I'm doing that because it's public domain. And then another Range Rover. Well, two Range Rovers performing rather differently. There is an effect of temperature here in this bar chart. Without paying much attention, there is a bar chart indicating whether it's hot or cold. And generally, the colder the day, in kind of the 6-7 degrees, this was winter, or the hotter day, closer to the 15 degrees, there was some effect of the air temperature. So it appears that the engine system knows air temperature. It appears it would adapt what we call the exhaust gas recirculation system, the EGR, exhaust gas recirculation system, to adapt and stop it. And the moment the EGR is switched off, the vehicle emissions will obviously go substantially higher. So in other words, I mean, why would this be the difference? Why would there be such a massive difference between what was the similar testing and similar? It's unclear to some extent. What I can tell you, here is equipment, the big laboratory equipment, where they connect the tailpipe to an analyzer, which is several cabinets big, and millions of pounds. Here is the PEM system connected to the back of the car with a tailpipe, and then an exhaust will be here. It's all done equally, to be fair. Trust me, this was done properly for many tens of vehicles. And this is the track. Well, first of all, the car in the track has an aerodynamic effect that is not as visible in the dyno. The dyno does know the aerodynamics because it has a CD, it has a coefficient of drag that sets the dyno wheels to be mimicking. But there is some effect. I think when testing, often the vehicle developers have been used the concept of flexibility. They've used the most favorable condition, and maybe it is the most favorable condition of those coefficients, and therefore is the most better outcome. The test temperature was different, I mentioned. The weight is slightly different, cornering is slightly different, and there may be some slight difference between the emission equipment. In fact, equipment was compared back to back. It was pretty good. So I think, in fairness, aerodynamics and flexibility, red and blue, are the two biggest differences. So is this a kind of cheat? No, it's not a cheat. It just happens to be the nature of doing testing in a non-representative environment. This is a bit closer, but it's still not representative. And the difference is phenomenal. So we then wanted to do representative testing. This is a bit like a story. The story says we're going to do real drive emissions. We're going to take the car. Here is the Fabia Skoda and TDI, and we then we'll take all the tens of vehicles in a test track, in the real environment, no test track, sorry, in the real environment. This is near Nuneaton in England, and in the we took the cars. I only witnessed, I think, twice, and we did a whole journey, which I'm just imagining by that trace. And that journey was 1.5 hours, continuous driving, it had real environments with traffic, pedestrians, traffic lights, high speed on the motorway with joining lanes and other vehicles on it. Included the prescribed urban, rural, and motorway portions, about a third and a third and a third. Excuse me, not far off. And it reverted back to Nuneaton, where the system was was checked and disassembled. Get ready for the next vehicle, and that was done for each and every one of those vehicles. And so that is the closest you could say one can come to real life, right? So if it's the closest we can come to real life, what was the outcome? Let's take Euro 5. Euro 5 is similar to Malaysia, so you shouldn't be terribly happy with your own vehicle levels, because I think they're substantially higher than they should be. When undertaken for all these vehicles, and the names and the models are there, well, if the standard was about 200, 180, the average on the road was bordering 1,200, 1,200 milligrams per kilometer. And all the other emissions will follow. So in other words, no matter which one, some are massively higher. So I already mentioned the Insignia, I already mentioned Range Rover Sport, and a few others, Hyundai, Santa Fe, there's a few others. And some rather good ones, you could say the Citroën C4, Peugeot 208, and some rather good ones and not so good ones. No matter what, 1,150 milligrams per kilometer. That is the average emission over a 1.5 hour drive. And what is the point of regulating for 180? There is a point, because the next slide will show you why there is a point of tightening it. If you look at the Euro 5, Euro 6s, these are most relevant to us. Do remember that most of these vehicles are still on the road. Do remember that it takes about 10 years or so, depending on the nation, to have a substantial turnover of vehicles. So no matter what, these vehicles are today on the road. And the levels of emissions are today a little better than they were. It will take some years for the fleet to renew. So Euro 6s, the standard was 180, great, sorry, 80. The average emission around 500. And some real huge outliers, the Peugeot 308, Renault Megane, no matter, and some fantastic performance. The VW Golf, of course, the one that hasn't got the engine, that had all the dodgy software. The Mini Countryman, outstanding. Audi, the Audi A3, and I think there's also BMW. Yeah, BMW X5, a rather big car, actually, performing beautifully well. None of them met the standard on the road, and the average about 500. So if you compare Euro 5 and Euro 6, you'll be satisfied with one thing. Euro 5s are better at worse than Euro 6. Indeed, regulating to 80 compared to 180 is better, because the whole thing shrinks down. But actually, if you take the average of Euro 6s is about 500. The average of Euro 5 is 1,150 or so. Still a long way from what we intended. And this is better visualized by the next graph, which is rather complex. I'm sorry, but I think, and I've only taken Euro 6s here. What I've done is I've taken the ratio of what they delivered on the road to what they should have delivered on the road, or rather regulated in the test environment in the lab. So where number one is parity. Any vehicle that makes 1, it means it's emitting 80. This is how Euro 6b, Euro 7 will be saying that we want to develop a conformity factor, a CF, and we set a number. Well, you can see that if we were to apply any conformity factors to any of these vehicles, there's only 3 meet anything less than 2.1. 2.1 being a possible number. The BMW X5, the Mini Countryman, and the Volkswagen Golf. The others are, not just 3, 4, 5, 6, 7, 10, 12, 13, 14 times what they should be. The average conformity factor of these super advanced vehicles, Euro 6s, is 6.2. And that is the evidence that we needed to say we are not getting to the standards that we would like our nations to be. Now, do remember that in some nations we still are Euro 4s, some have Euro 5s, and Europe is in Euro 6, 6A, and RD. And this is the evidence that was needed. We needed to tighten the emission standards because it all translates to the air quality, which translates to the healthcare and our ability to deliver an environment which is not just for those who are healthy, for those who have some breathing issues and everybody else, but particularly asthmatic children around schools, any elderly, and anybody else with a breathing underlying health factor. And everybody else will eventually be affected by it. So the evidence is astoundingly bad. The interesting thing about this is I made a plot here as I come towards the latter part of the presentation. I'm conscious of time. Is that we now did something rather naughty. We said, let's plot together the real drive blue for all these vehicles versus the simulated track following a very, very tight prescribed speed trace. And these are very different things. On the track, you're prescribing without traffic, without pedestrian, without traffic lights, a very precise, very tight testing procedure. In the road, you have not only the day change from morning, evening, it's usually done midday, in fact. We did it. It is also all the traffic, it's also the traffic lights, it's also pedestrians, also acceleration and deceleration, and the ability to drive just to drive, because they're all different drivers. Now, there'll be absolutely no reason why these two are correlated. And yet the evidence is strongest on the correlation. So clearly, you could say the way our diesel technology is enabled is not capturing the reality of the emission levels. Because whether you do a very narrow test, very tightly controlled on the roads, or you do it on 1.5 hours with real traffic, the numbers come up to be almost the same, which is rather shocking. And this is to do with the way the emission equipment is enabled. So, some observations. The very large difference between laboratory and track. There's some temperature dependency strategies they use. And the word here in italic is to protect the engine from damage. I can do, as a manufacturer, I can do all sorts of procedures. I can put in and enable, disable some procedures on the vehicle emission to enable some protection of the engine. And that under that framework, legally, there is a loophole. There's a loophole through which legally engine developers can get through because they are protecting the engine. Now, in some cases, yes, in some cases, no. And the evidence is strong for the latter than the former. The evidence is strong to say that observation I had a minute ago is not in line, and is not in line in magnitude, and is not in line with what the engine needs to be done to protect it. Right. The last part of my talk, as I come towards the end, is to discuss the emissions gap. And the emissions gap is to do with the following. If we have a technology through which we improve it, and in that improvement we get our emissions lower, is it possible, or is there any evidence that the emission levels in real life get worse? In other words, you regulate something which is in a tight environment of testing conditions. Does that mean that you might increase or decrease your outdoors real drive emission output? You would say that if you regulate something to lower emissions, you should be able to lower also the level of emissions on the road. So divergence will mean that while you get a benefit in a tight environment of testing, you're not getting a benefit if it's a divergence in the negative sense. You're not getting the equivalent a divergence in real life. Well, if you look at NOx, if you look at CO2, we see a bubble here, and this bubble is Euro 5 vehicles. I didn't put labels, and this is Euro 6s. Euro 5s have got better. So Euro 6 got better than Euro 5s. The averaging should be around 80. This is 180, mentioned many times in my talk. And here in the vertical axis is the divergence from road relative to dyno, where divergence of 1 means equality. It means the vehicle on the road is going to have a similar level of emission as the vehicle on the dyno. Well, there are no vehicles on 1. We know that. But there are many vehicles that as we diverge, we go down from the average, which is where those two broken lines cross, to that, the broken lines cross. Well, it looks as if we've gone from about 8, 9 to about 11. So there has been some divergence, and we better acknowledge that. We got better, everything is better, but the divergence relative to what we should be meeting, which is a better standard, on the road has increased. What about CO2? We look at CO2. Here is a plot of all the CO2 footprint of all those vehicles. Here in blue are the Euro 5, Euro 6 in orange. And you could say some vehicles are way out because they're bigger cars, they're bigger vehicles, unregulated, and they're sort of in the 200 grams per kilometer. You know, today's emission standards in Europe is 95 for new build, was why the axis starts at 95. Well, at that time, no vehicles, 70% of the vehicles would not be meeting that standard. In fact, none of them would be meeting that standard except hybrids. And here we got in the vertical axis, so we understand better, but still there's a lot of Euro 6s, Euro 5s doing rather well in CO2, not doing well in NOx. And here's the divergence. It's saying, how far is my CO2 footprint on the road relative to the testing on the lab environment? And if we take a 30%, it says 30% worse off, 45% worse off. So if you take this particular vehicle here, it's got better in the lab, but when you put it on the road, it's actually emitted 45% more CO2 than it should have. If we take that should have as a strong word, which is not legally binding. So you could say there is a divergence because the Euro 5s diverge in the real environment relative to the lab around 19%. While they got better on average to Euro 6 now diverge 25%, and some a lot more. So there is an effect of divergence. Our vehicles, while they're getting better in one aspect, maybe are not getting better in some other aspects. And CO2 being one, that there is some evidence of divergence, which is not just coming from me. So I think probably I'll just do one slide on the future, only to look at CO2, and we look at a trajectory. The trajectory being over time. I gave a lecture already on CO2, a long lecture on CO2, and this is one slide from that lecture at UTM. So in 2010, 160 being the figure, getting better on average, 135, about 2015. Today, regulated to 95, so it's a nice decrease of a CO2 footprint. And today, in fact, we are regulating to 0 at 2050, not even 80% of that, to 0 at 2050. So there's got to be a trajectory towards 0 or net 0. In here, I plot what I think is the lowest possible level of a diesel and lowest possible level of any hybrid. So that it's not going to take a long time before we are not able to meet lower CO2 footprint of our vehicles with either diesel direct drive or hybrids. So no wonder we're thinking, okay, we've got to do we do lots of electrification. Hand in hand with our electrification, we need to see the grid decarbonization to continue. We need to see that blue line to continue to net 0. So you see many drivers. The electricity network has to lower to net 0. The fleet will have to go outside the direct drive and outside the hybrids if it's going to meet 0. And additionally, we could have the option, just the last comment I make, could have the option of a net 0 carbon fuel, which is sustainably derived from the environment and produced so that we have a net 0 emission using still fuels, of course, so long as the air quality is kept to a good level. So many things are pulling our society, needing to decarbonize, needing to get better in our air quality, needing better fuels which have net zero carbon, getting to a standard which is not going to be purely driven by electric vehicles, but hybrid electric vehicles maybe. So many things are pulling us towards in this trajectory. I think with this I finish. Apologies, I had a few minutes where I stepped out by thanks to the internet, but hopefully we didn't waste too much time. With that, I think, Rafiq, I finished my talk.
Thank you, Ricardo. It was a very interesting talk. I think a lot of the data that you showed, I think probably is very new for people in the talk. So I now open for questions. So people in the audience who are listening, if you have any question for Professor Ricardo, please post a question. I think it should be in Facebook. We will ask him. While we wait for the question to come in, Ricardo, maybe I can ask you something. So you are very familiar with Malaysia and in fact Southeast Asia, and we know Southeast Asia is actually lags behind when it comes to emission regulation, right? So most of the regulations are done either in Europe or in America, and we tend to adopt it. But I think we had this private chat many times that socioeconomic of people in Southeast Asia is very different than Europe and America. So what are your thoughts on this? Like how we gonna catch up to the emission regulation, which is mostly coming from Europe and America, and to cater to our need, and so it will fit into our socioeconomic, especially not only Malaysia. I'm talking it's also in South Asia.
Great, thank you, Dr. Raju. Yeah. So I think I'm going to answer the question, but let me start with a comment.
Yeah.
If Southeast Asia does not decarbonize and does not air quality improve, there's no point to do it anywhere. So Southeast Asia is such a large conversion of individuals and people. And if you throw in India, and you were to throw in also Pakistan, and you might just throw in China for the sake of it, I mean, what is the point of us doing anything if those nations do not decarbonize and get air quality? So while, yes, in the UK we're getting better, the United States may be getting a little better, the rest of Europe is definitely getting better, we're just a minor proportion of the global planet CO2. So it is absolutely essential that Malaysia, as one of the center hubs of Southeast Asia, leads the way. Because I think if you don't lead the way, others might or might not lead the way. You are plugged in to enable to lead the way. So your question, well, that's my first comment. And the question is, what is this pull between development, social equality, social affordability, justice? These are all difficult questions. These are all hugely difficult questions that I think your former Vice Chancellor can talk a lot about, Professor Zaini, which I mentioned here as a very good friend. These are social questions. These are questions of pulling and pushing. But what it needs is a buying mentality. What it means buying mentality? It means that you, unfortunately, are going to have to pay more per kilometer traveled or mile. You're unfortunately going to have to be prepared to travel less, be prepared to do more lockdown activities, avoiding movement, like we are all getting used to now. After 4 months in my home, I'm still perfectly working harder than ever, in fact. So it doesn't go without commitment, I'm afraid. Who pays, how it is paid, I don't know. Wait to see.
Think about that. Okay. Thank you, Professor. There's a question from one of the audience, Mr. Ali, I believe. So thank you, Professor. So what is the best way to reduce emissions while using hydrocarbons fuels?
Okay, good question. Thank you. I think, the different ways of doing this. If you're in an environment that is polluted or pollutant capable, like Kuala Lumpur or in some other big conurbations, I'm afraid you won't be allowed to use hydrocarbon fuels. Why I say that? I think it is really hard to see how you're going to clean up enough in a large fleet of vehicles moving on our roads. So I think you're going to have to do hybridization. You could have hydrocarbon fuels in there, but as far as air quality, which I think is what your question refers to, we're going to have to switch off the machine. Or some fantastic engineers are going to come up with fuels that don't emit anything harmful. Okay, let's wait for that. But it's unlikely with the use of hydrocarbons. Now, in CO2, it's different. Because in CO2, you can have a net zero carbon sustainably derived fuel that enables you to be carbon neutral. That's okay. But the air quality is the major issue that you're asking me. The answer is you're going to have to have a fully integrated, intelligent vehicle that switches off once it knows the environment pollutant levels are high, which you can do.
Thank you. I think that probably is very right to say. Going forward, I do agree with you. I think hybrid probably is the best way forward, that we can switch mode. So in the city where air quality is concerned, so you can switch to full electric, right? And out of city, so probably you can burn a bit of fuel.
Yeah.
All right. There's another question from Hasbullah. So we are now in 2020. Are we on the right track towards achieving 80% or 100% reduction in emission, I believe, by 2050?
Right. Thank you, Hasbullah. Great to have your question during the talk. I think, are we on the track? We're on the track slowly. I think the difficulty is the jump, isn't it? We go for 95 grams per kilometer of CO2, and only very few vehicles will make 95 today. But still, there are some. So we're on that track. To go from 95 to 0 is not an easy jump, right? Because you've got kind of a big difference between those two levels. Are we on the right track? No. Do we want to enable technologies that get us to 0? Yes. We're fully committed to enabling net zero carbon. But I think it is hard to see how it would be enabled without using liquid fuels. I can see a large proportion of our cities becoming more hybridized electric or full electric in some nations. I cannot see how you get to net zero without a net zero liquid fuel that you would be able to use on your vehicle. And of course, on the cities, you wouldn't be able to use it. You would be able to use only an electric mode to enable air quality to be better. So are we on the right track? I think we are on the right track, but we haven't got the means, processes, and procedures that would enable it. So that's a strong thing to say. A dialogue is happening in the UK significantly all the time. Are we on the right track? We set the track, and yet we don't know the road, right? We don't know how we're going to get there, but we are on the journey. No question about it, Hasbullah. We are on the journey, and we've got some way to go. But we are on that journey. We still have to enable the journey to be safe and sound and deliver.
All right, thank you, Ricardo. Just touching partly on what you have mentioned. So what are your thoughts on hydrogen as a fuel?
So hydrogen, if it's sustainable derived, let's assume that we can recover it, deliver it from sustainable renewable energy, so it doesn't impact some other portion of a carbon footprint. I think it's a great fuel because, so the thing about hydrogen is that hydrogen is the molecule that enables all the other molecules. So hydrogen is the carrier through which, of course, we can do a fuel cell for heavy duty. We might do some fuel cell technology or hybrid or hydrogen-based combustion, both. Well, it's combustion hydrogen with hydrogen, which has other impacts around NOx, really still after treatment, or you're going to do a fuel cell. But hydrogen as a molecule will enable you to produce a sustainable liquid fuel, like methanol. So hydrogen, sustainably derived, is the cornerstone. I'm glad you asked me this because it's not a talk, but is the cornerstone of cleaning up all our fuel delivery systems. So anybody who wants to start developing hydrogen technology, technology to enable hydrogen, absolutely key to the future. At the moment, hydrogen production is more energy inefficient than almost any other procedure. So we need to enable the hydrogen energy efficiency. So Malaysia has a high reliance on fossil fuel, yeah, sure, and carbon, and you know, yeah, but let's have programs that enable hydrogen production, enable our economy, your economy, to flourish by being the producer of this molecule in a sustainable fashion.
Right, thanks. It's another question from Dr. Kogila Bani. So I think you have touched on this, but anyway, I'll ask the question. The acceptable limit and the emission level seems to be very variant. So I guess she mentioned between many parts of the world. So what do you think can be done to reduce to meet the healthy standard, quote unquote?
Yeah, thank you for the question.
Yeah.
I think it's quite a good question, because you know, no regulator is going to answer it.
Yeah, what is healthy standard?
There is no healthy standard. The only healthy standard is 0 in our cities. Okay, so some people are affected by very little. Some people are not affected by a lot. The fact of the matter is that the healthy standard, I'd like to answer your question, what is a healthy standard? My view is is that in the city, you know, perhaps the latest diesel technology is emissions are so much lower that you could accept in some time and locations, but generally not even that is good enough. So what can be done? Well, we've done a lot. If you look at RDE Euro 7 coming up, this is a fantastically reduced level of emissions compared to the baseline, but still may not be sufficient to call it a healthy standard. It's a very difficult thing for me to say, and I think we still need to do a lot better. So it's just on air quality rather than CO2. I hope I can help you. What is the future of internal combustion engine? How much? I must answer the question, right?
Yeah. So yeah, this is the question. So what are your thoughts on this?
So I think the internal combustion engine is changing, is evolving. The internal combustion engine is becoming less direct drive, more hybridized. It's being tuned, adjusted, and optimized for a narrow set of conditions. It's now able to talk to the battery system, able to talk to the motors and generators in a hybrid fashion. I think that will continue, and that will continue for the foreseeable future. The reason why it will continue for the foreseeable future is actually it is very hard to transition to a completely new technology in the time frame, cost, social acceptability, equality, and justice with a rapid change. So it's going to take time. I believe it will continue with us, and if we were able to develop a carbon neutral fuel, it would still continue for us for a long time. Heavy duty being one, but even on the outside the big cities, you still might enable IC engines to operate. But as time goes on, the pressure becomes stronger on them being absolutely clean, and hopefully the technology of EVs and plug-in hybrids revolutionizes in the next few years. Let's call it a decade. Let's call it a decade, a long time. Eh? And why would we go for ICEs in that environment?
Okay, Ricardo, thank you very much. I think the last question you have touched on that as well by Sham. So we are running out of time, so I think we have to close the show today. Ricardo, thank you very much for a very insightful talk, interesting discussion, and I believe everyone who joined have enjoyed. For those who want to get to know more about Ricardo and what we're all doing, just Google us at UTM Lokartik. Then contact us and we can carry on with more discussion if you want to. All right, Ricardo, have a good day. And we will log out, I guess, after this.
Thank you.
All right.
Thank you. Thank you all.
Okay.
Cheers.
Thank you.
Bye-bye. Thank you very much.
Thank you to the audience. All right. Okay. Bye-bye.
Bye-bye.